Hey guys, welcome in. Today I'm going to kind of have this video notes section, if you will, just because people are finishing up the final and working through some other things and stuff like that. So I wanted to make sure that I offered up this as a resource or a tool to help you go through your notes today before you try to complete your assignments and going through and doing different types of work. All right. So today our learning target is to, sorry, there's the bell. Find our domain and range of all functions. So that's kind of what we're thinking about when we're answering questions today, how we can write our domain and range for all of our functions, how we can use different interval notation to show that. All right, so the first thing we want to remember when we're looking at our notation here is to remember that our domain, okay, when we go through that, sorry, my pen was a little bit marked off there. Domain, when we're looking at that, those are all possible X values, right? Or we also call them input values. Okay, so we're thinking about that. That's what we talk about with our domain. Okay, and then our range. Let me try to get this set up here. Our range values, when we're doing that, okay, those are all possible Y values when we look at that. Okay, which is also our output is another way that we put those answers. Okay, so we're looking at domain and range. That's kind of where we're at, where we're sitting, how we're trying to answer the questions based on what we see and based on how we get those final answers when we look at our different types of values. So that's something that we've talked about a little bit with our first few lessons with this unit, but it's also something good to review here before we kind of get going too far into it. Okay, so just remember that's what you're looking at there when you have those answers. Okay, so when we're thinking about this, we're going to look at domain and range using interval notation. Okay, so we have our standard notation, which is what we're used to when we see this, and we kind of answer some questions based on that. We have our standard notation, we have our interval notation. That's what we're looking for. All right, so I'm going to use my highlighter here for this part of it. You guys can kind of highlight as you go too. But in our standard notation, we see something like this. Remember, we're looking at that sign and we're looking at the direction it's open. So when it's open to the variable, right, we read that as x is greater than that overall value. In this case, it would be greater than that 2 value. That's what we're looking at for that one, okay? So we want to keep that in mind as we go through and answer these questions, and we write these things in that notation, right? We're used to that standard notation when we look at it, but we're also highlighting the interval notation today as well when we're going over and listing all of these values as possible answers and solutions to our function between our inputs and our outputs, okay? So in that standard notation, we've got x is greater than 2. That's how we read it. But then in our interval notation, right, we're trying to list out all of the possible values that could make that part of the function true. Okay, so we look at this one, we look at it and we read it in interval notation. We have x is greater than 2. That's still what we're saying here. But we notice we use our parentheses, right, in our brackets for this. So in interval notation, all of our possible values, right, for x are 2, and then anything greater than that. So it's to positive infinity. Remember that little symbol there? Looks like a sideways 8. That's our infinity symbol. So we list this in interval notation, right? It's when we have that. So a note here, we use parentheses for an open dot on the graph, okay? So if that means that it's continuing on forever and ever, whichever direction, we use those parentheses. So in this case, right, if it's an open dot and then it goes everything greater than that, we have parentheses around both, so everything greater than 2. So 2 is not included, but then to positive infinity, right? And note infinity always has those parentheses, right? Because it continues on forever and ever when you're looking at that, okay? So another example down here really quick, when we look at this one, we have standard notation, right? This is x is less than or equal to 2, right? And that's because of that underlined symbol there, right? X is less than or equal to 2. So this looks a little bit different because it's all the values less than or equal to 2, right? So if we're looking at that, that's why there's a bracket here, okay? It could equal 2, but then it's everything less than that. So we start with our negative infinity with the parentheses because that always has a parentheses, the infinity part. And then it goes up to 2, and 2 is included, so that's why there is a bracket there. So remember that when you're looking at this and you're answering that, right, and you're trying to answer the questions, you will use those closed brackets for a closed dot on the graph because it's included, okay? And infinity, again, always has those parentheses, and the reason it has parentheses is because that continues to go on forever and ever. So we'd have those values in a positive or negative direction when we're looking at listing out our intervals here. So jumping back into some examples with this, it says finding domain and range from a graph. First thing we want to do is identify all of those possible domain values. Look left and right. Remember, domain goes from left to right, right? Because those are our x values. When we think about this, our x values are our domain values, right? Okay. And then identify all of the possible y values, the range values, by looking up and down. So your y values are your range values, and we get those from looking up and down, because that's where we get that. And then we're going to write using our interval notation. So when you see a graph like this, okay, and you want to list those out, if we're looking at domain, we have a closed point here at -5. So we actually put a bracket around that -5, but then it's an arrow, right, a continuing line here as it goes on. When you look at this graph, I'll kind of zoom out or scroll down a little bit so we can see this. But you'll see it's a closed dot there at -5, but then an arrow that continues on forever and ever. Even though it's going at a slow rate, it would continue to get bigger and bigger in those x values. So that would be, our domain would be for this one, a bracket around that -5 value, because that's included, and then to positive infinity with a parentheses around it. That's how we would do that one. Close bracket to positive infinity. That's how we'd list that one out. Okay. If we're looking at our range for this one, again, same thing. There's a closed dot up here, right? Okay, a closed dot at our upmost value for our y values, but then it continues on with that open arrow that continues on forever and ever. So you can see kind of that teal line that is representing the range here. So my range for this one again would be a closed number at I need to delete that. That's why we do this, right? Our range goes up and down, so actually we would continue on to negative infinity. So that needs to be the first part of that with a parentheses around it. Okay, and then up bracketed to that -5 value, because that's the highest value. Not a -5, +5 this time, because that's our highest value in terms of our y values. Okay, so there's an example of our interval notation, our -5 to positive infinity, right, with a bracket around it because it's included, a closed point when you talk about your domain, right? And then your range, the lowest values goes all the way to negative infinity down below, but then your highest value is a +5 and it's a closed circle, so we'd also have a bracket there as well. Okay, so using interval notation there, we can write that out and give our domain and range when we look at that example. All right, let's take a look at another one here. So it says, what if you have an open dot and a closed dot at the same value? Open and closed dot at the same value. So that's something that we have to talk about and think a little bit. So as you see here with our range, right, our domain first, let's look at our domain first, our x values, right? It says the extent of the graph, the horizontal extent going left to right, is -3 to 1, but you'll notice there's an open circle at -3 and a closed circle at 1. So the domain of this function, if we were going to write an interval notation, would be a parentheses around -3, because that's not included, right? Okay, so a parentheses around -3, and then a bracket around 1, because that's +1, right? +1. So we have parentheses there if it's open circle, right? Parentheses if it's open circle, or if it's to infinity. So that's why we have a domain here of -3 with a parentheses around it to +1 with a bracket, okay? And then if I look at the y values, my range values here, right? If I'm looking at those, again, I have an open circle at -3, okay? An open circle at -3, and then a closed circle. Oops, sorry, not -3. We're looking at our y values this time. Sorry, up and down here. So I have an open circle at 0, right? That's the highest that this y value goes up, and a closed circle at -4. So when I list out my range for this, since the extent is from 0 to -4, I would have a bracket around -4, okay, bracket around -4, okay, and then it also have this closed point here at 0, even though there's an open point there. So we'd also have a bracket around 0 here, because this one is also a point that's on the graph. It's a closed circle, okay, so that looks a little bit different. So it says, what if you have an open dot and closed dot on the same value? We go with a point that's on the line. Since this is a point on the line, it's a closed dot, it's included, right? So when I look at my range here, I also need a bracket around 0 when I'm listing this out. So it's from -4 with a bracket included, because that's included on the point, to +0, or just 0, right? And there's a bracket around that one as well, because that's a point that's included on the graph, okay? So that's something to take note of. Even if it's an open circle here, we also have a point at 0 there as well, right? And so we have a couple different domains of ranges of 0, y values, and so that's why that looks like that. All right, so let's take a look at one more example here, and then we'll get to some of the ones from your paper homework assignment. So if we look at the domain for this function, right? I'm looking for our domain, so I'm going, domain. Actually, let's go ahead and do that in red because that's what we've been doing, domain in. Let's go back and do red here. So my domain, right, is what I'm looking at when I go left to right. My x values going this way, right? So the domain for this one is a closed circle, a closed circle at -4, so there's the bracket there because that's included, right? But then it's everything in the positive direction from there. So it's everything x is greater than or equal to -4, it looks like in this function, right? So a bracket around -4 because it's included, and then it goes everywhere in that positive direction. So this is what our interval notation looks like for this one, right? Okay, and then if we look at the domain for this one, so if we go back and look at the domain for this one, and we try to write that out, okay, our domain was this, and then our range is a closed bracket around 0, okay, and the reason it's a closed bracket around 0, again, because that's the lowest value, right, because range represents your y values, so that's going vertically up and down, right? So my lowest value is the one where I want to start, closed point at 0, right? And then it continues on in that positive direction, so it'd be to positive infinity with that parentheses as well, okay? We can list that out. So my y values, right? Y is greater than or equal to 0 in this one if I'm thinking of that standard notation when I'm writing this out. So you guys can see kind of how you're going to list each one of those based on your functions, okay? So what you've got is a couple different things. You're going to do a paper assignment today, right? You're going to do a paper assignment today, and you're also going to do your IXL. So when you guys look at your paper assignment, you're going to have a list of a bunch of different functions, right? A bunch of different functions, and you need to list out your domain and range values for each one of them, okay? So we look at this, and we're looking at domain and range for each one, right? Domain and range when we're listing this out. We're going to write it there, okay? Here's the good thing about these first two examples, right? You're looking at your domain, which is infinite because it's going in both directions, right? And it's your range. So both of these would be from -infinity to positive infinity when you look at your domain from left to right, but then also your range because it's going up and down, continuing. There's no closed points. So that would also be a -infinity, to a positive infinity for this one as well. Okay, over here we've got kind of the same thing. This function looks a little bit different, right? But when you're going through and you're listing it out, right, your domain and range, they continue on forever and ever in both directions. So again, this one would also be the same thing when you look at it and you say your domain is from -infinity to positive infinity because it's going on forever and ever in terms of left to right when you look at this one, and then your y values are also doing that. Okay. When we see like something like number 3, that makes it a little bit trickier, right? It makes it a little bit trickier. So when I'm going through here, we have points that are kind of stuck here, and we're writing this out, okay? What I want you guys to understand is when you're looking at this, you've got some different things that you can write out here. So domain and range, right? So domain is my values from left to right, okay? And my range is my values vertically, horizontally, right? Okay? So if I'm looking at my domain here, it looks like I've got a closed point right here on the graph, right? That's included, and a closed point that's there on the graph, okay? And so if they're closed, those would be included. Those would be included. So it looks like I'm going from a -1 domain to 1, 2, 3, 4, or 1, 2, 3, 4, 5 to 5. That's what I'm looking at. Closed brackets because those are included. Those are closed points that are included on the graph. But it's anywhere my x values are anywhere in this graph between a -1 and +5 value. Now, when I look at my range, that's a little bit trickier, right? It's going to be a bracket around 0 because that's my lowest value here, right? I have a range of 0 here, -1, 0, and at 5, 0. So I've got a bracket there. And then the utmost point is here on this graph. So it's up 1, 2, 3. That would also be a bracket because that's included on the graph. There's nothing that's continuous here, so I'm not going to infinity. So I'd have 2 brackets on that one, okay? One more example, and then I'll let you guys kind of get to work here today with what you're doing. So if I look at my domain and my range on this one over here, okay? My domain, I've got a closed point here and a closed point there. So I'm kind of limited in terms of my domain on this one. It looks like I'm at 1, 2, 3, 4, 5, 6, 7. So I've got a domain of -7 values up to 1, 2, 3, 4, 5, 6 positive 6. I'm going to go ahead and bracket that one as well because that's a closed point on those two dots. So that's really important, okay? When I look at my range, I've got a lower value here, or lowest value there, and it looks like my highest value would be up here for my range. So I'm looking at that. The lowest value is down here at 1, 2, 3, 4, 5. So a -5. So again, a bracket because that's a point that's included on the graph. And then my highest value is actually up at 1, 2, 3, 4. Is that where that one is? I guess I need to probably erase that and look at it one more time. It's almost all the way up there. 1, 2, 3, 4. Yeah, I will say it kind of hits there at 4. It's kind of in between your X values there, but we'll go ahead and say that it hits right there at 4. And so we've got a 4 with a bracket around it as well. Okay, so that's what you're going to do as you go through all of these. So you have some different types of functions. The biggest thing that you want to look at really closely is those points and where they're included, because sometimes it's a little trickier when you're looking at some of them. And some of these aren't, normal graphs, if you will. They've got some different symbols and styles and things like that. Some of them are not continuous. They have just plotted points. So that's something to keep in mind. Some of them are a mixture, right? Like this one, you'll see here, you've got a closed point, but then an arrow that goes on forever and ever in that direction. So that changes some things too. And just make sure that you're doing your best in terms of how you're looking at your domain and range. And so some of these kind of repeat as you go through with what we're looking at in some of these questions, okay? So the idea is to work through the rest of those questions and try to identify your domain and range, okay? And you have your answer sheet here. It looks like there's, I believe there's 20 some total, if I remember right. We're looking at 20, 28, 30, 32. So you've got a few there that go along with that. You also have your IXL assignment that's in the folder today, so you want to make sure that you are completing that as well as part of your assignment, okay? Some of you guys are going to be able to work on this in class. Some of you guys may have to work on it at home more just because you're trying to finish up your final, whatever the case may be. But I did want to make this video here really quick for you guys to go through this, okay? So you can finish up your notes and then start going with your assignments, and then make sure you have both of those completed and ready to go for tomorrow. Thanks, guys.